let's look at how to solve systems of equations involving two variables where we're dealing with systems that are not necessarily linear. And this first one I've drawn x squared plus y equals 6, which is a parabola, and x minus y equals -4. And you can see that it meets in two places. So from the graph we can see where the line and the parabola meet. We're looking for those points. And there's not just one way to do it, but we could solve by substitution. For x squared plus y equals 6, we can just isolate our y. We get y equals 6 minus x squared. X minus 6 minus x squared equals -4. And so this would give us x squared plus x, and then we have minus 6 equals -4. Gives us minus 2 equals 0. Then of course that factors. And we get x equals -2 and +1. So there are two solutions. X is -2. And when x is -2, we can plug in y equals 6 minus -2 squared, which is 2. And when x is +1, we get y equals 6 minus 1 squared, which is 5. So we have x equals 1, y equals 5, and x equals -2, y equals +2. Oops. Okay. Here we have an example of two equations, and just like we did the process of elimination involving two linear equations, we can use the process of elimination to involve two nonlinear equations. So notice for the top equation, if I multiply by 4, I get 20x squared minus 4y squared equals 0. Add the two together, and we get 23x squared equals 0. So we get x equals 0. And if we plug in x equals 0, we also get y equals 0. So the solution is at the origin. Okay, so we have a system of two equations and two variables, and these are obviously nonlinear. But this is just an example how we can take two equations that are not linear but still use our elimination method. If we multiply the second equation by -1, we would have x squared plus 3xy plus y squared equals 22, and then -x squared plus xy minus y squared equals -6. And you can see that when we do this and add the two equations together, our x squared terms and our y squared terms are going to cancel out. And we're left with 4xy equals 16, or xy equals 4. And we can solve for one in terms of the other, so maybe x equals 4 over y. And at this point, so we did elimination just to simplify the equation, and in this case it was obvious because we had, x squared terms in both equations and y squared terms in both equations, and you could see how they would cancel out. But that leaves us with x equals 4 over y, And then we can take one of the equations. Let's just take the second one. It looks the most simple. And substitute. So we're kind of doing a combination of elimination along with the substitution method. And so we get 4 over y plus y squared equals 6. And so that's going to be 16 over y squared. Wait, there was a y right there. So the x was 4 over y and then times y, doing that substitution. So 16 over y squared minus 4 plus y squared equals 6. And remember our little process, when we have a extra denominator, if we multiply through by that denominator, so multiply through by the y squared, and we get 16 minus 4y squared plus y to the fourth equals 6y squared. Clean that up a little bit, and we have y to the fourth minus 10y squared plus 16 equals 0. Okay, so now this is going to, a little process we can use is look at this as a quadratic in form. And we've done that before. This actually factors, like if we let our x equal y squared, then, and not this x, but if we let, say, u equal y squared, then we can think of this as u squared minus 10u plus 16 equals 0. And then we see that it's a quadratic equation. So this is quadratic in form, although not quadratic. Anyway, it factors as y squared minus 8 times y squared minus 2. So using the factoring method, we can solve for y squared, and we get y squared is equal to 8 or positive 2, which would give y equals plus or minus the square root of 8 and y equals plus or minus the square root of 2, or plus or minus 2 square roots of 2 and plus or minus the square root of 2. Now, when we actually take those individual values of y for the solution and then plug them back in over here, x equals 4 over y, then our xy's are going to be x equals the square root of 2, we'll say plus or minus the square root of 2, and then the corresponding y value would be 2 square roots of 2. And then we also have when our x is equal to 2 square roots of 2, then our y value is equal to the square root of 2.